Hi guys, welcome to this set of videos, and this set of videos is going to follow along with the notes that come out of your textbook from Chapter 4, Section 5. And this section is going to be all about completing the square. Now, let me just refresh your memory because we kind of took a break there in Section 4 to deal with imaginary numbers. So here's where we're at. In Section 3 of Chapter 4, we looked at factoring, and I gave you guys a list of 6 methods for factoring, and we looked at the first 4 of those methods in Section 3. The first one was GCF, right? We look for a GCF. If we can factor out a GCF, we can then solve our quadratic. If GCF didn't work, option number 2 was difference of squares. And we looked at how you can factor a quadratic using the difference of squares formula. The third option was perfect square trinomials. And again, the perfect square trinomials had 2 formulas. And if the quadratic fits the formula, then it told us how to factor that quadratic. And then option number 4, if the perfect square trinomial didn't work, then you had to go to factoring a general trinomial. And we looked at a number of different methods for factoring a general trinomial, and we kind of decided that the easiest way to factor a general trinomial was that method I showed you known as slide and divide, the slide and divide method for factoring a general trinomial. But what we're now going to do here in Section 5 and in the next section, which will be Section 6, we're going to look at those last 2 methods that were on our list. Option number 5, completing the square. So we're going to go ahead and look at how completing the square can help us factor a quadratic equation. And then in the next section, Section 6, we'll look at the 6th method for factoring a quadratic, which will be using the quadratic formula. So with that background, and now that we've kind of caught up with what we were doing prior to taking our little complex number tangent line there that we were off on, we're back to factoring, and here's what I'm going to need you guys to be able to do. Your objectives or learning targets. By the end of this set of videos, you should be able to solve a quadratic equation using the square root property, which is actually what we're going to look at first. And then you should be able to solve a quadratic equation by completing the square. And I will just tell you right up front, completing the square is hands down one of my favorite things to do in algebra. I love completing the square. I think this method is a ton of fun. It makes a lot of sense, so I really think you're going to like it a lot. With that, let's just jump right into this then. The square root property. Here's what the property says. Some quadratic equations can be solved by taking the square root of both sides of the equation. This method can be used to solve many equations like the ones below. So we'll take a look at those example problems on the next page of the notes. But before we take a look at it, I do want to remind you of this because it's very, very important. Remember that when you take a square root, you must do plus or minus the square root of whatever you're taking the square root of. And here's the reason why. If I were to do a positive 2 and square it, positive 2 times a positive 2 gets me 4. But that's not the only option. Remember, if I take a negative 2 and I square it, a negative 2 times a negative 2 also gets me a positive 4. I get the exact same answer, positive 4 and a positive 4. But I get that answer by doing 2 very different things. Here I multiply a positive 2. Here I multiply a negative 2 by itself. So you need to be very, very careful when taking the square root of both sides of an equation. For example, the one that we've got right here. When I take the square root of an x squared, the square root and the square root cancel each other out, leaves me with just an x. Awesome. But on the other side, when I take the square root of 4, I must remember, you have to remember to do plus or minus the square root. Why? Because of this right here. Both a positive 2, when you square it, gets you a 4. There's the plus 2. And a negative 2, when you square it, gets you a 4. So there's the negative 2. And you get your 2 answers, which you should always get when solving a quadratic. You should always wind up with 2 answers because you have 2 solutions, right? That quadratic will cross the x-axis in 2 places. In this case, it's at +2 and -2. So with that quick refresher about why you must do plus or minus anytime you take a square root, let's jump into this and try a couple of example problems. Here's the way that these are going to work, and this is also a great refresher because what we wind up with here are perfect square trinomials. And we're just going to go ahead and factor these guys. So I want to solve using the square root property, and here's the way it's going to work. I take a look at what for you guys is the left-hand side of the equal sign, and right away I recognize that I have a trinomial, right? 9 is a perfect square. My leading coefficient is a 1. So I should immediately be able to split this up into 2 binomials. What I need is what times what, right? My first terms are going to be what and what. It's got to be the same thing, right? They have to be the same number. What times what gets me an x squared. That's the easy part. It's an x times an x, right? Because if I were to FOIL these binomials out, x times x gets me x squared. But now I need to know what times what, and it has to be the same number in this case because 9 is a perfect square. What times what gets me 9, multiplies to 9, but those same 2 numbers also sum to a positive 6. And this one's easy. Of course, it's a +3 and a +3. Well, now we know that because those binomials are the same, x plus 3 times x plus 3 is an x plus 3 squared. That's all equal to 36. And now hopefully you can see where that square root property comes in. In order to solve for x, I'm going to need to take the square root of both sides. So I'm going to do that. Don't forget to do plus or minus. I just made a huge deal of it, so I'm going to try really hard not to forget. And this one's easy. 36 is a perfect square, so I wind up with x plus 3 is equal to plus or minus 6. Now, to get the x by itself, subtract the 3 to the other side, and we get our 2 solutions. I will have a -3 plus 6, which of course would be a +3. And I'm going to have a -3 minus 6, which would be a -9. That's the way these are going to work. There's a few more here on this page of the notes, so feel free to work ahead. Come on back and check your answers when you get done. So here we go. Let's do a few more. Yeah, looks like I got 2 more. So let's run through those. Once again, I take a look at this. I recognize the left-hand side is a trinomial, and it's a perfect square trinomial because 36 is a perfect square, and my leading coefficient is 1. So I'm just going to go ahead and jump right in to splitting this up into binomials. Well, at this point, I think we should all be very, very comfortable. My first terms are going to be x and x because x times x gets me x squared. But now the question is, I need 2 numbers that multiply to 36 and sum to a -12. And because 36 is a perfect square, they're going to have to be the same number, right? They got to be the same number. And in this case, it looks like it's going to be a -6 and a -6. Well, because those binomials are the same, I write them as x minus 6 squared. And that's where the square root property comes in. I'll take the square root of both sides. When I take the square root of x minus 6 squared, the square root cancel each other out. Don't forget to do plus or minus. And 25 is a perfect square. So once again, a nice, neat problem comes out. Plus or minus 5. Add the 6 to the other side. Right? It's a -6, so I'd have to add it to the other side. And I get my 2 solutions. I have x plus 5, which would be 11. 6 plus 5, which would be 11, and 6 minus 5, which would be 1. I got one more for you here. Once again, it looks like I have a trinomial, and 64 is a perfect square. Man, I love these perfect square ones. We just jump straight into two binomials. It's got to be an x and an x. I need two numbers that multiply to 64. This number and this number have to multiply to 64 and sum to a negative 16. But because 64 is a perfect square, they got to be the same number. Minus 8. Which means that I have x minus 8 squared is equal to 49. Take the square root of both sides. Got to do plus or minus. I love it. 49 is a perfect square. So I'm going to wind up with plus or minus 7. And I got to add, right, negative 8. So I got to add the 8 to the other side. And I get my two answers. 8 plus 7 would be 15. And 8 minus 7 would be 1. I got a few more example problems for you when it comes to using the square root property to solve quadratics, but the next ones get a little trickier. So head on over to the next page of the notes. I'll meet you guys there.